In this video, I will show an adobe house of representation. But first of all, this is an adobe house which can be built by modified bricks. I will explain how modified bricks are all, how the modified bricks can be produced, their test results. We have also 3D Max pictures. After the house is constructed, you will be able to settle in such a house. It's a very large house, 200 square meter, as I remember. One project set and structural analysis document is for this one. Here you see a garage and very large house. Roof is plain concrete. I mean, there is no slopeless roof. With zero slope, the roof is designed. This is one-story house. You see windows here, doors. This is the appearance of it. The other one is two-story. Actually, one can build this first-story house, adobe house, and then when the person has more money, can construct the second floor. This is the appearance of the two-story adobe house, which can be constructed using the modified bricks. Now I am sharing all the projects with everyone. I will put it in my site, so you will be able to download it from my website, which is that one. I'm an assistant professor. I'm an assistant professor in Uşak University in Turkey. I have written a lot of books in Turkish and in English. Some of them are written in English, some of them are written in Turkish. Some of them are translated in English. You can download these documents, free civil engineering drawing and introduction to civil engineering. And the rest of the other documents are in Turkish. And these are also my printed books. Two of them are in English. I will put all related all documents related to Adobe construction to this site. It's important for me that you subscribe to my channel. Let's start the presentation from the introduction. In the scope of this capstone project, this project is completed when I was working in another university as a capstone project. It is aimed to produce an adobe brick from the soil of Famagusta and develop a design for a single-story masonry building. Briefly, adobe brick masonry structure consists of small building elements placed one on top of the other, following a particular bonding pattern and bound together with mortar. Masonry structures using small elements have very little tensile strength. As a result, the good strength and good stability of a masonry structure using small elements is dependent on the interaction of several factors, which are quality of the adobe brick itself, quality of the masonry, the interaction between the brick and the bonding pattern and the mortar, form of the building system, which should be suited to the compressive forces applied, quality of the tailing of the building system, notably ensuring good protection against water and humidity, quality of construction and workmanship. This workmanship. Now let's speak about adobe bricks. Adobe bricks are rectangular mud bricks shaped in forms, dried in the sun. That's why they are easy. And then laid up in courses in the wall with mud or cement mortar. I prefer using cement mortar because the tensile strength of the mortar determines the tensile strength of the whole structure. Advantages of adobe bricks: the exact amount of shrinkage in the brick is relatively unimportant as long as the unit remains intact. All shrinkage takes place before the bricks are laid in the wall. Labor requirements are extremely flexible. You can build your house by yourself. Adobe balances the air humidity. That's why it is the preferred structure. Adobe stores heat. Adobe reduces environmental pollution, and it's easy. Always reusable. Saves material and transportation. You can reduce your transportation expenses because you will use the soil where you will build your house. Adobe bricks. How to make bricks? You may want to make your bricks by hand and using simple equipment, or you can buy them commercially. But generally, everyone produces the Adobe bricks by himself or herself because of money. Manual labor is, of course, the historical method of brick making. It is still used in adapted forms, often with the help of small tools and or light machines to puddle the soil completely. Make rectangular forms of wood or metal, lay them on the ground on a smooth area, and place mud in the forms by shovel or bucket. Do not make the mixture too wet, or the mud will slump or run after you remove the forms, or it may shrink and crack excessively upon drying. Which soil is preferable to produce an adobe brick? Not all the soils can be used for brick making. Many will not form bricks of adequate strength. A very sandy soil is weak, and so is a loamy or organic soil. Most suitable soils contain some clay or silt, but too much of it will cause too much shrinkage and will result in warping and cracking. Ideal mix. Ideal soil is that one. These are the photos when we are sampling soil. We have to first check whether our soil is enough good to produce a adobe brick, adobe soil. Actually, I added cement. I modified the brick by adding cement, and then I did some other different things to make the brick surrounded by concrete. In order to make it rainproof. First, the specific gravity of both soil samples are determined using picnometric tests according to ASTM D854 in the laboratory. The specific gravities of the soil used in this project are so much. Then using sieve and hydrometer analysis, clay amounts in both samples are determined. Clay amount in soil samples taken from campus and Geçitkale and Famagusta are around 1%. This is the particle size distribution of soil sample taken from the campus. This is the clay amount. So it's around 1%. If I draw a line from here, first a vertical line, and then with a horizontal line, I come here, it should be 1%, around 1%. And Here we see again the clay amount is around 1%. These lines with different colors helps me to understand visually what is the percentage of the ingredients. This curve is obtained from sieve analysis and other curve is obtained from hydrometer analysis. As you see here, cent amount can be seen from here. If I draw a line here, and then I come here, it's approximately 95. If I come here, it is approximately, let's say 25. It's less than 20. Let's say 25. 95 minus 25 gives me 70% sand is included in my soil sample. That's why I am using these lines when I am growing this particle size distribution of soil. The assessment of the soil has finished here. Now, since the clay amount in both soil samples is around 1%, apparently not enough to work as a binder for adobe construction. In ancient years, people used mud, and the clay amount in this mud plays the binder role to bind the soil bricks to each other, to bond them to each other. That's why, and also the tensile strength of the soil bricks are determined by its binder. That's why its amount is important. An alternative idea producing soil concrete bricks made of soil, cement, and aggregate. That's why I thought to add cement, not only as a binder, also direct I mixed the cement into the soil. Below in a table, try and mix compositions to produce soil concrete bricks are given. So this is the modified adobe brick. It's soil concrete adobe brick. You see the cement amounts added to soil per weight, as a percentage added to the total soil weight, and also water amount, and also aggregate amount, percentage. And aggregate sizes, you see here. Some aggregates are also added to the soil to increase its strength. These are the molds, our molds. This mold is created by ourselves. These are the soil concrete bricks under moisture curing, subject to moisture curing. And under compressive load, the 7 days and 28 days compressive strengths of the adobe bricks are given here. This is the mold designed by myself and by my students. A masonry building design is composed of designing mortar, masonry walls, masonry wall reinforcement, wall bonding pattern, coursing of masonry wall. This is about the method of construction of masonry walls, windows, doors, lintels or lintel beams and openings, bond beams, which are made from concrete foundations, interior partitions, plumbing, electricity, floors, roof, finishing and paintings. Mortar. A mortar is a mixture of aggregates, sand and fine gravel, with a binding agent, generally cement or lime, to which water is added in previously determined proportion. Okay. Walls of masonry, adobe construction, you see here very old adobe house. Generally, the walls may vary from 20 centimeter to 60 centimeter thickness, depending upon the size of the blocks. Wall height is usually 2.5 meter or 3 meter, or 8 to 10 times the wall thickness. Bond beam. Bond beam bonds the slip foundation is placed beneath the load-carrying masonry walls and bonded all the masonry walls together from at the bottom level, and the bond beam is placed at the top of the masonry walls and bond them together at the top level. Roof may be here as a gable wall, but I prefer, instead of making a gable wall, a flat roof I prefer to build. Roof covering can be made from traditional roof covering materials, as they are used in concrete or steel structures. Windows you may use any standard type of wood or metal sash. Set wood frames in place and build up the adobe walls around them. Shape the glue adjacent bricks at the ends to allow for mortar to hold metal ties, which are then nailed to the wooden window frame. Metal sash. Doors. There I might have made a mistake here. No, it's not a mistake. You probably will use lumber frames around doors, set them in place like windows, build the walls around them, and attach them with metal strips or nail 1 inch in the mortar joints. Allow a total of 1.25 centimeter to 2.5 centimeter in height for vertical shrinkage in the mortar joints. Strip foundations are generally used under the masonry walls. You see here excavation to build strip foundations. Walls or partitions within the house may be of thinner adobe sections or of wood frame, but I prefer using the same thickness in the inner parts, because not only the vertical dead load is carried by the walls, but also the lateral earthquake load will also be carried by the house, and also for to carry the vertical load, that load, it's also, I think, better, according to my idea, to construct the inner partition, I mean the inner walls, with the same thickness as is used for the outer wall, exterior walls. Plumbing and electric wiring. In planning the adobe house, you have to consider the need for running rough plumbing and wiring through foundations and concrete floors. Okay, I can read this. Okay. We have one foundation plan, one floor plan, first story plan, roof plan, north elevation, south elevation, east elevation, west elevation, and section drawings. As architectural drawings. And then as plumbing drawings, all plumbing pipes and facilities are drawn and given in this document. This will be loaded to my site as a complete document. So by means of this document, you can take approval from your municipality to construct your house without paying any money, and you can construct it by yourself. All circuits and lamps and electrical wires and earthing facilities are also given in this drawing. You can also check the correctness of the drawings. Structural analysis of masonry single-story building made of Famagusta soil is done by means of Ansys. It's a finite element software. These are the results. Here you see only the walls without strip foundation and roof, which are made of concrete. And masonry walls strength is one which are obtained from tests. This is the von Mises stress. It's under depth load and live load combination. The maximum von Mises stress obtained is 0.3 megapascal, which is smaller than 1.5 megapascal masonry wall strength. So von Mises stress is a criteria, a function of all physical stresses, and it's very small in comparison to the masonry wall strength. Our adobe house, single-story adobe house, houses walls can sustain under the combination of dead and live loads. Here you see here the strip foundation and roof, which are made of concrete, which can be constructed from C20, 28 days. Compressive strength is 20 megapascal. Here you see, as a result of the Ansys analysis, maximum von Mises stress is 2.3. Very low in comparison to the C20 strength. And this result is obtained under this load combination. Now this is the dead load, live load, and under earthquake load. The von Mises stress revealed in the walls, it's very small. And again, now the concrete parts, roof, the flat roof, the strip foundation is included to the results of von Mises stress. It's still very low. Okay. But in the analysis, window and door openings are not taken into account. So anyway, if I make an opening in the wall, I shall replace something which compensates the lack of stiffness caused by the opening. As a result, for earthquake loads. As a result, for example, I did something like that. I thought to build door, and for doors and windows, they might be produced by means of something like that. An indeterminate frame structure made of steel or made of concrete. And the lateral stiffness of the opening can be assumed as so. This is the wall elasticity modulus, wall moment of inertia, and L. Okay, when the load acts in this direction. For this pier, I have two piers, one here, one here. Similarly, the two piers' lateral stiffness can be assumed with this equation. And now I come here. If I set them equal, if both stiffnesses are set to equal, as piers and as wall, I will get this formula. And from here I get this equation. Here in this equation, EP is the elasticity modulus of piers. 30,000 megapascal for C20-25, and this is the elasticity modulus, not strength. 210,000 megapascal for steel. And whether you produce this indeterminate structure, which is a frame which constitutes a frame for window or door, shall be a monolithic structure made of steel or concrete. And HP is determined by means of this formula. For window frame, 10 centimeter is enough. If the window frame is made of steel. For doors, if it is made of steel, 12.5 centimeter thickness HP equals to 12.5 centimeter is enough. Okay. And any other calculations are explained here. Now I continue from here. I don't want to waste time. Hand calculations are explained here. Also, in detail explained in the PDF document report. This is the flat roof reinforcement drawing. The AutoCAD drawing you will find also in the documents which you can download from my website. Again, this website, I will put it later. Please subscribe to my channel. And for bond beam reinforcement documents are also provided. And for strip foundation reinforced drawings are also provided. Okay. Which are included in the set? Architectural drawings, some explanations and drawings about how you will produce your mold to produce bricks, concrete, soil concrete bricks, electrical drawings, plumbing drawings, structural analysis, input file for Ansys. You can use this input file to make the analysis and use Ansys in the batch mode. You can make some modifications in the input file and make analysis of similar Adobe from Adobe constructed buildings. And head calculations are also explained here. For two-story and single-story Adobe house, you can use those. I just want you to subscribe to my channel. That's all. Thank you very much.